Welcome. Today we'll be discussing about data structure lab programs. Okay. Yes. So data structures laboratory. This is the third semester lab. Subject code is 18 CSL 38. Okay. So we are discussing third program in our data structures laboratory programs. Okay. Third program, it states that we have to design, develop and implement a menu driven program in C. Okay. So for the following operations on the stack of integers. Okay. We have to consider a stack of integers, and stack of integers is nothing but array implementation of stack with maximum size max. Okay. So initially we will initialize one maximum size for our stack, and we will do the following stack operations. Okay, first we have to do push an element on stack, then pop an element on stack, then demonstrate how stack can be used to check palindrome. Okay, so demonstrating stack to check palindrome means we have to push the elements, pop the elements, and then we have to check whether it is palindrome. You know what is palindrome, right? So reverse of the given element, if both are same, then it is called as palindrome. Then we have to demonstrate overflow and underflow situations on stack. Okay, so overflow and underflow situations, they are not the separate. Okay, whenever we are doing push and pop operations, okay, these conditions or the situations will arise. So whenever we are doing the push operations, we will show the overflow, and whenever there is a pop operation, there will be a situation called underflow. Okay, so then they have told to display the status of the stack. Okay, display the status of the stack means you can display that either your stack is empty, or you can display the now what are the elements which are there in our stack. Okay, so one thing we have to remember, that after checking the palindrome we have to display the status of stack, because after checking the palindrome the stack must be empty, isn't it? As we push the elements and we have to reverse, so we have to reverse the entire elements. So after checking the palindrome we have to check the or display the status of the stack. Okay, so in the status of the stack you will be displaying that either stack is empty, or if stack has elements you have to display the which are the elements which is present in our stack. Okay, so then we have to exit from the program, and they have given that we have to support the program with appropriate functions for each of the above operation. Okay, so each of the above operations whatever they have given, we have to use or support them with some appropriate functions. Okay, so we have to use a push function, pop function, okay, palindrome function, and also display function. So that this means that we have to support the program with appropriate functions for each of the above operations. Okay, so this is our third program. So we'll see, first we'll see what is stack, then we'll go with the snippets, and then we'll execute the program and we'll check the output. Okay, so according to this, we have to implement a menu driven program in C. Menu driven program means we have to use the switch case, where it will show the menus like 1 is for push, 2 is for pop, 3 is for palindrome, 4 is for status, okay, 5 is exit. So like that, they means that menu driven program means we have to use the switch condition. So first we'll see what is stack. You know, right? Stack is an ordered list in which insertions, or also you can call them as push or adding. So, and deletions is called as pop. Okay. And main thing is that both the insertion and deletions, they are done at one end. That is called as top. Okay. Top is the stack pointer which will be used throughout the program to check the position of the pointer, or check the position in our stack. Okay, so always stack follows LIFO method. That means the last element which is inserted or which is present on your top will be removed first. Okay, last in first out, hence it is called as last in first out operation. Okay, so stack is an ordered list. Ordered means it is a sequential list where you can perform insertion and deletion. Insertion is called as push, deletion is called as pop. Okay, and both are made at one end called your top. Okay, top is a stack pointer here which we are using. And your stack always follows LIFO rule, that is last in first out. The last element inserted will be inserted into stack is first element to be removed. Okay, this is the representation of your stack, how it looks. Initially your top will be equal to -1 because you have not inserted any element. So top is equal to -1 means your stack is empty. Always you should remember that top is equal to -1 means our stack is empty. So when you go on adding the elements or pushing the elements, see we have pushed A, so your top gets incremented. So you should remember that in pushing operation our top always gets incremented. See here again from top 0, always your initialization starts from 0. Imagine that we have taken a size of 5, where stack size is 5, so it starts from 0, 1, 2, 3, 4. Okay, 4 will be our size, stack size. Okay, since it is started from 0 to 4, okay, we will name from 0 to 4 and your maximum size will be 5. So as we go on pushing the elements, our top will get incremented. Okay, see we have pushed element A, so top has been incremented. First we'll increment the top and then we will push the element. See again we have put next element is B. If you want to insert B, our top get increments, so top is equal to 1 and it will push the element into that position. So whenever we want to perform pop operation, so first the element will be deleted and then our top will get decremented. Okay, in push operation top is always incremented, in pop operation top is always decremented. Okay, so as I told, in top you can, in push operation you can check for the overflow, because whenever you want to insert the element there must be a space, so in that position we'll be checking for the overflow situation. Okay, in decrementing or popping of the elements, so if you want to delete one element there should be some elements, right? So here we'll be checking for the either the stack is empty. Okay, if the stack is empty and you're trying to delete the element from your stack, then here the situation is underflow. Okay, so this is what we have to do whenever you are performing the push operations. You have to check for the overflow situation, and whenever you are performing the pop operation we have to check for the underflow. Okay, so these are the two situations which they have told us to demonstrate. Okay, demonstrate overflow and underflow situations on the stack. So separately you cannot call a overflow underflow function. Whenever we are doing the push and pop operation, inside that first we have to check for the overflow and underflow. Since your stack size is see we have, I told 5 and till 4, top is equal to 4, till there you have in, pushed the elements, added the elements, and again if you want to add there must be space, right? So at that time it will show the situation that your stack is overflow, you cannot add any more elements. Okay, so this is clear what is stack, how the insertion and deletion takes place. In insertions our top gets incremented, you have to increment your top and you have to insert the element. Since because top is equal to -1, initially our top will be equal to -1. Okay, and that situation shows that our stack is empty, and whenever your top is equal to the maximum size, that is 4, so that time it means that our stack is full. Okay, these are the two conditions we'll be seeing. So now briefly we'll see the algorithm for this push and pop operation. Okay, so to push the elements we need a stack, right? And we need a top stack pointer, then the maximum stack. Okay, and then the item means the element. Okay, we should know the size of our stack, that is called as max stack. Okay, so this procedure pushes an item onto a stack. So first we have to check whether stack already filled. This you know, right? When it will be already filled, if your top is equal to max stack, okay, then printf overflow. As I told, your top is equal to 4, then again you cannot push. So that time you have to print that overflow and you have to return. Okay, or else you have to set your top, you have to increase your top. Okay, in that position you have to insert the new item. Okay, into the new position. Then you have to return. Okay, this is your algorithm for push. Then algorithm for pop. So to pop, we need stack, top and item to be deleted. Okay. So here we don't want maximum stack. Okay. So to delete top element from stack, we have to check whether stack has an item to be removed. Isn't it? If there are element, then only you can remove. Okay. If your top is already equal to -1, then you have to print that underflow. Okay. Means there are no elements to delete and you have to return. So if there are elements, what you will do, you will initialize the item to stack of top. Okay. Means to that pointer means 0th position to be deleted. So that will be initialized to your item. That is the item that is assigned top element to your item. Then you can easily delete the item and then you have to decrement. Okay. So you have to top is equal to top -1, decrease your top by 1 and you have to return. That means after deleting you have to decrement, because now you have deleted the element from top is equal to 1 means when you decrement your top, it will move to top is equal to 0. So in that position again you can delete the element. So this is the basic algorithm for your push and pop operation. Okay. So now we'll see the snippets for the all the functions. Then we will execute this function. Okay. See, void push, this is a function as they have told, support all the operation with the separate function. So first is your to push. So to push what we need, we have to you have to define the element, okay, int element, okay. I'm declaring an element. So always I told in push function, we have in push operation, we have to check for the stack overflow. If your top is equal to size -1, size is, see, imagine you have initialized maximum size for 5. So size -1 means 5 minus 1 is 4. So if your top is pointing to 4, that means that your stack is overflow, right? It is already size is full. You cannot insert any more elements and you have to return. Or else you have to increment the top. See, it is a pre-increment. So first we have to increment the top. Okay. In that position, we have to insert the element. Why we have to do the increment the top means, see, top will be equal to -1 initially. So if you increment, it will go to top is equal to 0. Okay. Then you are pushing an element. So after increment, you have to push the element into that position. Okay. And okay, this is your push operation. Then comes your pop operation. Pop, if your top is equal to -1, it means that stack is underflow. Underflow means there are no elements to delete. Then you have to return -1. Else, you have to return the S of top minus minus means you have to return the element in that position. And then it is a post decrement. After deleting that element, returning the element means removing the element. Then you will decrement your top. Okay. So if your top is equal to -1, you cannot delete. Okay. And you have to tell that it is underflow. If your top is equal to the maximum size, you cannot insert any more elements and it is overflow. Okay. So next they have given is palindrome. Okay. So palindrome, you can check either for integers or for strings also can be checked. Okay. Palindrome is a operation where, okay, it is a condition where you can check for both integer for your numbers and your strings. Okay, but here we are checking for numerical palindrome. Okay, in palindrome we are using two mathematical functions, that is your modulo and your division operation. And with the help of your modulus and division operation, we will reverse the element and then we will pop the elements. Okay, first we will reverse, then we will pop, and then if your element is equal to reverse of the element, then we will print that the element is whatever the item or the element we have given is palindrome. Okay. So palindrome or not, it is dependent on if your element is equal to reverse, then it is palindrome. Okay. So see here, you can see that initially I've taken one reminder, reverse we need, okay, one temporary element we need, and I is equal to 0 and the element which we want to check for the palindrome. Okay. So first condition is that when you call the palindrome function, okay, you will have this you will initialize these terms. Okay, then you will ask to print a number to check for the palindrome. Imagine you have given 1 to 1. Okay, we will check for this now. So first condition is for temporary, we have assigned our element. Okay, your element that is 1 to 1 is assigned to temporary. Okay, so after assigning, it will enter into this while loop. Okay, in while loop, you can see that while temp not equal to 0, condition is true, right? Your temp is 121. You have assigned your 121 is the element, and in this step, we have assigned this 121 to temp. Okay, so while temp not equal to 0. Okay, so while 121 is not equal to 0, yes, condition is true, right? So it will calculate the remainder. Remainder is equal to temp modulus 10. Modulo operation means, you know, right? Modulus is finding the modulus is finding the remainder. So modulus of 121 modulus 10 is remainder is 1. Okay, so what they are telling in next step, they are telling that push that remainder. Okay, so you are pushing that remainder into the stack. Initially your top was equal to -1, so we are pushing the remainder, that is 1, to the stack. See, I have pushed here. Okay, then we have to calculate the new temp value. Okay, each and every time we cannot take 121. Okay, so new temp is equal to temp divided by temp. Okay, here division means we'll take the model quotient. So 121 divided by 10 is 12. Okay, our new temporary value is now 12. So again you have to check the, until this condition fails, you should be go on checking. Okay, while temp not equal to 0, temp is 12 not equal to 0. Okay, it is not equal to 0, so it will enter into the while loop where we have to calculate the remainder. Okay, so next is what it will come now, 12 modulus 10. So 12 modulus 10 is 12 modulus 10 will be 2, right? Will be equal to 2. So our remainder is now 2. Remainder is equal to 2. So you will push the remainder into stack. So see, we have pushed now 2. Okay, so now we have pushed off remainder means we are pushing the remainder to, okay, 2. Then temp, new value of temp will be calculated. So what is the temp value now? 12, right? So 12 is your temp is equal to, temp is equal to 12 divided by 10. So what will be the quotient? 1. Okay, 12 divided by, so temp is now 1. Okay, so again it will enter into the while loop. While is temp is 1. Okay, is 1 not equal to 0, true, right? So 1 is not equal to 0, so it is true. So it will enter into the while loop where you will find out the remainder. Remainder is equal to, what is your temp value? 1, right? 1 modulus 1 modulo 10, which is equal to 1 modulo 10 is equal to 1. Okay, so now your remainder is 1. So remainder is 1. Remainder is 1. So we will push that into stack. So we have pushed that remainder into 1. Okay. The remainder is equal to 1. According to this, push remainder okay, push of REM. So remainder element should be pushed. So it is 1. Okay. So like this, we have to push. We have to use this modulus operation because to know the position, okay, 121 directly you cannot push, and 121 is, you cannot take it as a single element. If you take it as a single element and if you push, it will be, first element will be 1 to 1. So since we want to check the palindrome, we have to reverse. So we will split according to its tens, okay, according to its position, and we will push into the stack so that it will be easy to pop. In popping also we have to take care of the position. Okay, so again now you will check the temp. So temp is equal to 1 divided by 10, which is 0. Okay, so 0 not equal to 0, condition, it is fail, right? It is equal, so it will come out of the while loop. So we have pushed the 1 to 1 element into the stack. So after checking the palindrome, we have to check the status of the stack. Okay. Sorry, you have to reverse the element. Okay. So to reverse the element, we are using this since I told. See, reverse is equal to reverse plus pop of power of 10 comma I plus plus. Okay. So reverse is this, while top not equal to minus 1 means where our top is pointing to 2, right? From 2 to 0. So while top not equal to minus 1, your top is pointing to 2, right? So 2 not equal to minus 1, yes, true. So it will enter into our while loop. Okay. So while loop reverse is equal to, we are finding the here reverse of that of. Okay. So reverse is equal to reverse plus, you cannot just reverse because you cannot, if you go on just popping out, you cannot find the position since 1 to 1 they have their own positions like tens, ones and hundreds. So to retain its position means 2 should be retained in its tens position only. So for that purpose we'll be using this power. Okay, so that purpose we are using modulus and division operation. Then reverse is equal to reverse plus pop of star power of 10 comma I plus plus. Okay, you should remember this. To perform the palindrome we need this operation. So reverse, we are finding out the reverse element. So reverse is equal to 0. Initially we have initialized reverse is equal to 0, right? Then pop off. So in second position, which is the element 1, right? So we are popping 1 and power of 10 comma 0. I is also initially initialized to 0. So, okay. So 0 plus 1 power of 10 to the power of 0 is 1. Anything to the power of 0 is 1. 1 star 1 is 1. So 0 plus 1 is 1. So first element is 1. Okay. After you reverse, first element you get is 1. So until you fail, this condition fails, you should be go on doing. Okay. So now the top will move to 1, right? So second position finished. So now it will move to, this is second position. Now it has to move to 1. So in one position, is this condition true? 1 is not equal to minus 1. Yes, it is true. So reverse is equal to, uh, what is the new value we have found out? Now reverse will be no more equal to 0 because it is 1. Okay, 1 plus, in first position what is there? 2 is there, right? See, in the second position 1 was there, in first position 2 is there. Okay, so 2 star power of 10 comma I plus plus, initially it was 0 since it is a post decrement. Okay, your I will turn to 1. Okay, so 1 plus 2 star 10 to the power of 1 is 10, 2 tens are 10, it is 20 plus 1 is 21. Okay, so next position is 0, right? 0 not equal to minus 1. Yes, true. So it will enter into our while loop. So reverse is equal to, so what is the element? Your reverse is, what is the number? 21. Okay, 21 plus, what is the element we have to pop? 1. 21 plus, so in our zeroth position, what is the element present? 1. Okay, star power of 10 comma 2. So what is it? Which will be, equal to 21 plus the 1 star 10 to the power of 2 is 100, right? So 100 into 100. So it is 100. 100 plus 21 is 121. So reverse is equal to 121 now. Okay. After, your stack pointer will be decremented and it will be minus 1. Is minus 1 not equal to minus 1? Condition fails and it will come out of the while loop. Okay. So next condition is, we have to check whether our element is equal to reverse. Our element was 122 and reverse what we got is also 121. Sorry, element is 121. Reversing of that element is also 121. So you will print that it is palindrome. Okay. If you give 123 and reverse if you not get, so then we can print that it is not a palindrome. Okay. So then we will check the status. Okay. So next operation is to check the status of the stack. So to check the status, as I told, after checking the palindrome, we have to print whether the stack is empty, isn't it? So once we insert and pop all the elements, stack must be empty. So int I top is equal to minus 1, then we will print that stack is empty. if this condition fails, if your top is not equal to -1, so then we have to print all the elements in our stack. So how we will print? From the pointer which is pointing, okay, the stack pointer which is pointing from I is equal to, it will be pointing to that position till it is -1. Okay, after printing all the elements, we go on decrementing, okay, 2 1 0 like that, and then we can print all the elements. Okay, this is what checking of the stack. So now we will type the program and we will execute. Okay, so understood. So till now we saw the logic of the program. So in Turbo C++, we will execute and we'll check the output. Okay, so we'll start the program. Hash include stdio.h, hash include conio.h, hash include math.h. Why we are using math means because we are using the two operations like modulus and your division operations. Okay, and globally we are defining the max size hash define hash define. We'll take it as size. Okay, let it be 5. Initially we'll declare 5. Okay, then globally we are declaring the stack, okay, of size. Okay, and we are assigning, initially we are assigning top is equal to -1. Always it will be top is equal to -1. Okay, so as they have told, to implement the push operation, so first they have told to support with different, they we have to appropriate functions should be used. So first we are using void push. Okay, so this is your function declaration. Okay, we are declaring this push function, so where we can perform. We have seen the snippets, right? In push operation, what we have to do first, we have to check whether our stack is empty, right? Whether we have the space in our stack. So, which means that if top is equal to size -1, that means size is 5. 5 minus 1 is 4. So, if your top is already pointing to 4, then what it will print? It will print that stack is stack overflow. Okay, so it is overflow, you cannot insert any more elements. So snippet we have seen, now we have to see the execution. Okay, then it has to return. Yes, so else what it has to do, it has to take the elements. So to take the elements, it has to first increment the stack pointer, that is top, and in that position we will assign the element. Element is what we have declared there. Okay, so this is the push operation. Okay, so s of plus plus top is equal to element. So in that position we will insert the element. Right, this is your push operation, only this much. Okay, this is for checking of the situation or the condition of stack overflow, and then this is to insert the element. So next is pop. So in pop, so here we don't need any elements, it will be there. So we are not declaring. So here what we have to check? We have to check for the condition if your top is equal to -1, right? If it is equal to -1 means there are no elements to delete. So you will print that printf stack is underflow. Means there are no elements to be deleted. It is underflow. Okay, then you will return a -1, or else you'll return what you will return? You will return the elements. Okay, so s of minus minus. Okay, as I told, after deletion we have to decrement the top. Okay, so this is the pop operation. Okay, so next we have to call the palindrome function. Okay, palindrome function. Void palindrome. You know, we want integer type one reminder. Okay, reverse to find the reverse of the element, which will be initially initialized to 0, and one temporary variable to calculate. Okay, then I is equal to 0, and then our element to be checked. Okay, so then next printf, we have to enter the element. Okay, enter the number. Since it is an integer palindrome, we will enter the number to check the palindrome. To check palindrome. Okay, so we will read that number. Scanf percentage d ampersand element. Okay, so initially we will assign our element to temporary variable. Okay, so to check the or to push the elements, we will go for the modulus operation and the division operation. So to check that, first initially we have to check whether our temp is not equal to 0. Till then we have to perform this. Okay, while operation. So while of temp not equal to 0, we have to calculate the remainder. How to calculate remainder means how we will get the remainder by using the modulus function, right? So temp modulo 10. Okay, so your reminder will be, and we will push that reminder into. Okay, so after pushing we will calculate the new temp value. We will calculate the new temp value by using the division operation. So temp is equal to temp divided by 10. Okay, so then next, after finding out this, after pushing the elements, now we have to pop. So pop operation is like finding the reverse of the element, right? So popping will be done from top. Okay, so top till it is not equal to -1. Okay, till our top is not equal to -1, we will be performing this. Okay, while top not equal to -1, what we have to do? We have to do the reversing of the operation. How to do? Reverse is equal to reverse plus pop that element. Okay, pop off, we'll call the function here, and we'll multiply that with power of 10 comma I plus plus. Okay, the position. So why we are doing this? To retain its position, to retain each and every number's position, we are we have to reverse in such a way that their position must not change. Okay, so this is the reverse function. Whenever our top is not equal to -1, reverse value will be found. Okay, reverse is equal to reverse plus pop of star, a pop of the elements. Okay, which is pointing in that stack pointer, power of 10 comma I plus plus. Okay, when it fails, it has to check whether the element we have given is equal to the reverse element which we have found. Okay, If they are equal, what it will print? It is equal, it has to print f, it is palindrome. Okay, the element is palindrome. Else it will print, else it has to print not a palindrome. Not a, you can write the element is not a palindrome. Okay, so not a palindrome. And this is your, this finishes your palindrome operation. Okay, palindrome function or operation. So now next is, according to our program, next operation is to display. Okay, so to display, we have to take int I. Okay, for the for loop, if your top is equal to -1 means stack is empty. That is the initial condition, right? What we have declared. So we will print that stack is empty. Else we have to, else we have to print all the elements. Okay, else for I is equal to top, okay, where our stack pointer is there, from there to, it has to go on print by decrementing the I. It has to print all the elements. Okay, printf percentage d. Okay, we will print one by one slash n comma s of, okay, so to all the, in the all the stack, all the elements in the stack. Okay, so this is the function for your push, pop, and palindrome and display. Okay, so now we'll write the main function. Okay, in main function they have told we have to use the menu driven. Okay, so to use menu driven we have to go with switch. Okay, so first we need choice, means which operation we want to perform. Okay, and the elements which we want to insert. Okay, we will give the clear screen. Okay, so first we have to print. Okay, we have to, since it is a menu driven, we should ask the menu, right? First, what we want to do. First is our push operation. They have to select the choice. Okay, first is push operation. Then next is pop operation. Pop operation. Third is they have asked to check for the palindrome, right? To check palindrome, to check the palindrome. Then we have to display the status, okay, status of our stack. Display. Then last they have asked for exit. Okay, so if you press 5, it has to exit. Five. Okay, so we will take the condition while of 1, it has to execute infinite times. Okay, printf. So first we have to ask for the choice. Enter the choice. Enter your choice or enter the choice. Okay, then we will read their choice. Percent choice. Okay, so now we'll write a menu driven. Okay, we'll enter into the switch. Okay, so depending on the choice they have given, we have to call the function. Okay, so case 1 is, so we will ask here in case only to enter the elements. Okay, to push into the stack, we'll ask enter the element. Okay, it has to be pushed into your stack. We will read that element. D ampersand element. Okay, so we have to push. Okay, to push, we have to call the push function. We are calling the push function, and we have to break. Okay, so next is case 2 is pop, right? So we will assign element is equal to pop function. Okay, it will pop that and it has to print. Okay, if your element is not equal to -1, okay, then you have to show that you have to print that which element we have popped. Okay, element popped is %d. Okay, to print the particular element which has been popped. PL. Okay, then you have to break. Okay, then case 3 is to check the palindrome. So for that you can directly call the function. So in that function we have written the logic to solve the palindrome. Okay, then case 4 is for displaying. Okay, we can print one statement. Okay, because since they've given to check the status, so we can print that the status of stack. The status of stack is, okay, then it will print the elements. The status of the stack is, okay. To show the status, we need a display function and then break. Okay. So case 5 is exit. So this is our main program. Okay. We can execute the program. So we will save. We will save as stack.c. Okay. We'll compile the program. Okay, sorry. Oh, sorry. Okay, 0 errors. Now we can run the program. Okay, it is asking for the choice. Okay, enter your choice. Okay, 1. We will push the element. We will push 10. Enter the choice. Again, we will push the L. Okay, push operation will perform 20. Then we will check the status. The stack is, see, first is 10 we have pushed, then 20, isn't it? So now we'll perform the pop operation. So it has to delete our 20. See, element popped is 20. Okay. So now we'll check for the overflow and underflow condition. Okay. Underflow we will check again, pop operation. Okay. So popped is L2. Again, if you give, see, stack underflow. Okay. We have already deleted both the elements. So there is no element to delete. So it is showing that stack underflow. Okay. So we will check for the stack overflow. And, okay, sorry, enter your choice 1. 20, enter your choice 1. 30, enter the choice 1. 40, enter the choice 1. 50. So how many elements? So now we'll display the status. Now we'll check for the palindrome. Third is our palindrome. So